Hello, I'm going to go over this worksheet, bonding and electronegativity. And it talks a little bit about that here, where we can figure out what type of bond it is based on the differences in electronegativity. And that's what we're going to work on today. So I've got two charts which I'm going to be referring to, or two pictures here that I'm going to refer to. The first one is going to tell us what type of bond we have based on the difference of electronegativity. So carbon and hydrogen, if there's a bond between them, carbon's electronegativity is 2.55 and hydrogen's is 2.20. You subtract one from the other and you get a number, 0.4. That 0.4 is going to tell you what type of bond. And in this case, it would be a nonpolar covalent bond. I'm going to do a couple of these for you, show you exactly how to do it. But what we're looking at is how strongly one atom pulls at the electron. Remember, ionic bonds, one of them is going to completely take that electron. So it pulls very strongly at that electron because it will take it. Covalent bonds, they share the electrons, but there's different types of covalent bonds. In a nonpolar covalent, they're sharing it pretty equally, fairly equally. In a polar covalent, what it's saying is it's still shared, but it's unequal in its sharing. So in this case, like the carbon is going to take the electron a little bit more than the oxygen. All right, so anyways, let's get to the charts. Down at the bottom here, we have our bond, sodium and fluorine. So element 1, what I want to write down is Na, so I know which one I'm talking about. And I'm going to write down the electronegativity for sodium, 0.93. Next one is fluorine. Fluorine is here at 3.98. So F, 3.98. And then I figure out the difference. So take whatever one is bigger, 3.98 minus 0.93 equals, right? 3.98 minus 0.93 equals 3.05. All right, so my number 3.05, if I look up on my chart, it's bigger than 1.8, so this is an ionic bond. So I write ionic. And then the last part here, more negative atom. It's saying which one pulls at the electron harder. It's whatever one has the larger number between fluorine and sodium. Well, fluorine has a larger number, so it's more negative. Let's do another one down here. I've got carbon and oxygen. So carbon, 2.55. Oxygen, 3.44. The difference, remember I'm going to take whatever's bigger, 3.44 minus the smaller one, 2.55. .89. Well, I look up here for 0.89, and that's in between these two, 0.89. So that's going to be polar. Oops, sorry. It's going to be in between these numbers, 0.89. So that's polar covalent. Which one is the more negative atom? Whichever one has the higher electronegativity. So in this case, it's oxygen. The larger of those two numbers. I'm going to do one more with you here, and we're going to go to the back, and we're going to do this one here, hydrogen bonded to hydrogen. Okay, so that one looks a little different. H. And I look on my table, 2.2. Well, my other one's a H also, so I just write the same thing, H 2.2. I can still do the math. The difference between the high and the low one, 2.2 minus 2.2 is 0, right? Well, on my chart, 0 is below this 4, so it's this way. So this is a nonpolar covalent bond. So non-polar covalent. And which is more negative, the larger of the two, or they're the same? So I'm just going to write hydrogen, not distinguishing between one or the other one. Because in this case, neither one is more negative. They're equally sharing it. Okay, thank you very much. Hope this helps.